Hello everyone, welcome back to the Blue Team training series. This is an introductory guide to Blue Team operations. I just want to take a couple of seconds to thank our sponsor Linode for making this series possible. In this video, we're going to be exploring intrusion detection with Snort. Alright, so the objective here is to detect network intrusions with Snort. Now, if you're not familiar with Snort, let's get started by getting an understanding of what Snort is and how network intrusion detection systems work. However, before we do that, let's get a high-level overview of what we will be covering. So we're going to be starting off with getting an idea of what intrusion detection systems are. We'll get an introduction to Snort. We'll take a look at how Snort works, where Snort can be placed within a network, which is very important. We'll then move on to the practical demonstration, where we'll take a look at how to install and configure Snort. We'll also be exploring the Snort configuration file and how to write custom Snort rules. Now, one thing that you need to take into consideration here is that we will be we'll be focused on using Snort 2 as opposed to Snort 3, and I'll be explaining the differences between the versions in a couple of seconds. The prerequisites are the following. You need to have familiarity with information security concepts. You need to have familiarity with Linux and various command line utilities. You need to have a good understanding of the OSI model and the layers that make up the model, because we'll be dealing with various types of protocols and multiple layers of the OSI model. You also need a functional knowledge of TCP/IP and UDP, and familiarity with HTTP and web technologies. All right, now that we have that out of the way, let's get an understanding as to what intrusion detection systems are and what they're used for. An intrusion detection system, also known as an IDS, is a system that allows you to actively discover threats, attacks, or intrusions on a network, intrusions on a host or the services that are running within a network. Now, there are two types of IDS solutions based on the placement. Firstly, we have a host-based IDS, also known as an HIDS. This is typically set up on an individual host on a network, and a network IDS, also known as an NIDS, is placed within a network to monitor the traffic to and from all hosts on a network. So an HIDS is just set up to monitor the traffic for one particular host system, whereas an NIDS, which is what Snort is placed within a network depending on your requirements to monitor the traffic to and from all hosts within that network. So an IDS system or an IDS is a system or host that is planted within a network to capture traffic and identify malicious activity based on predefined rules, after which the malicious activity is logged and a notification is sent to the relevant parties informing them of an intrusion. Now, the actual types of rules you can write will allow you to determine or to essentially specify what you want done for specific types of network activity or for a specific packet. So you can either choose to log that particular packet, or you can enable logging globally and display the actual alerts on the terminal, therefore informing individuals or the relevant parties that there is an intrusion. And one of the great things that you can do is you can actually configure Snort to essentially output or to essentially log all malicious activity into JSON format that can then be integrated with Splunk. And of course, we'll be covering Splunk and how to do that. So we are primarily going to be focused on how to use Snort to or how to set up an intrusion detection system with Snort on our local network, right? Now, one thing that you might have noticed is that intrusion detection systems are typically coupled with the functionality to also perform intrusion prevention, whereby specific rules can be set to drop packets that are malicious or intrusive. So why am I saying this? Well, we are focused on intrusion detection, whereby we're simply using Snort to monitor the network and the traffic within that network to identify threats or intrusions. we're not really focused on doing anything about it. So we're not going to be, taking a look at how to block or how to drop packets, even though we will be covering it. Our primary objective is to actually, essentially identify, these intrusions that are occurring on a network. So what is snort, right? Because I've thrown around the term or the word snort quite a bit. Snort is a popular, free and open source IDS IPS system, so intrusion detection system and intrusion prevention system, that is used to perform traffic or protocol analysis, content matching, and can be used to detect and prevent various attacks based on predefined rules. Snort has been in active development and has thousands of users and contributors that develop rules or rule sets to keep Snort up to date with the latest attacks or the latest intrusions. So the way I want you to think of a rule, because I've mentioned rules quite a bit here, is if you take a look at a firewall, a rule is essentially that. It's just a rule that specifies what to do with a specific packet or with traffic from a specific port, etc. And it's the same thing for Snort, whereby you have the ability to, at a very basic level, log or essentially notify or alert individuals of specific traffic. So, I can notify the administrators or the security analysts that there is an FTP connection, for example. Now, one of the great things with Snort rules is you have the ability to perform signature matching, whereby based on the content contained within the packet, I can identify a signature and I can then utilize that signature to detect an intrusion or an attack. And I'll give you a practical example of this during the practical demonstration. All right. Now, in order to understand how Snort works, you need to know that it has three main operational modes. All right, so you have packet sniffing, where it collects and displays network traffic like what Wireshark does. That's fairly simple. We can do that with Wireshark. We then have packet logging, which collects and logs network traffic into a file. Again, Wireshark also does that, and that's why I actually covered Wireshark to begin with, because we will be using it to actually analyze the logged traffic. But what we're focused on is the network intrusion detection operation mode that analyzes packets and matches traffic against signatures specified within rules, or matches traffic against the rules that you have specified. Now, Snort detects malicious traffic or attacks by leveraging pattern matching. When active, Snort captures packets, reassembles them, analyzes them, and determines what needs to be done to the packet based on predefined rules. So if you install and configure Snort, but don't, you disable the default community rules, and you don't have any of your own predefined rules, then, Snort is pretty much non-functional at that point. So what the message I'm trying to convey here is that rules are, the core are at the core of, the functionality of Snort. So Snort rules are very similar to a typical firewall rule, whereby they are used to match network activity against specific patterns or signatures, and consequently make a decision as to whether to send an alert or drop the traffic in the case of the intrusion prevention system mode. All right. Now, one of the great things about Snort is that it has a large amount of rule sets created by the community that are very useful to begin with. Now, why are these important? Well, they're important because the community essentially generates rules for the latest attacks or exploits, so that if you get the latest rule set, then that means that your network is up to date in regards to detecting these new types of attacks or intrusions, which is absolutely fantastic. Now, another great thing with Snort is that the actual process of writing rules is extremely easy to understand and to actually do yourself. Which means if you are a security analyst and there is a new exploit developed, you can essentially perform an analysis on that exploit and generate your own Snort rule to detect that in the event that attack is performed on your network or the network that you're actually protecting. So let's talk a little bit about the Snort versions, because I think this is very, very important, and there could be a confusion, with what version to use. All right, so one thing to note is that Snort was initially developed in 1998 and has been continuously improved since then. What does that mean? It means that Snort has been an ongoing open source project, and it has had a lot of contributions. And of course, given the fact that it is open source, the typical release, the actual mode of release that they've utilized is a versioning system that in my case makes a lot of sense, whereby, you know, we currently have two versions of Snort available. We have Snort version 2.x, so that means, you know, whatever version of version 2, because there are many variants, but ideally you want to use the latest version of version 2. So version 2 is the de facto version of Snort, and is the version of Snort that is typically deployed or is most widely implemented and has the most rules or rule sets for. And then we have Snort 3.0, which is the latest version of Snort that features improved efficiency, performance, scalability, and usability over Snort 2. Not to say that Snort 2 is slow, sluggish, or you know, does not offer any good usability or scalability functionality. It's just an improvement on top of Snort 2. In this video, we will be using Snort 2 as it is the most widely implemented version and has extensive support, documentation, and rule sets created by the community. One thing to note is that eventually we will be migrating to version 3, and version 2 might as well be deprecated. However, I do not see that for the foreseeable future because, as I said, one of the issues that Snort has faced is the fact that when they released version 2, that version was, that's essentially when Snort started becoming mainstream, and a huge number of their customers or, you know, users who use Snort are on version 2. And in order to migrate to version 3, there are a few things you need to take into consideration. The most important of which is the actual rule format or the actual syntax for writing rules, whereby rules written for Snort 2 will need to be rewritten or converted to the new Snort 3 format. And of course, in the case of Snort 3, the Snort configuration file is programmed in the Lua programming language. So there's a lot of changes, and the reason I'm focusing on version 2 is primarily because this is the easiest and best way to actually get started with understanding Snort, learning how to use it, and of course implementing it within your own network. Now let's talk a little bit about the Snort rules, because I've mentioned them quite a bit. So Snort has three types of rules or rule sets. You have your community rules, which are free rule sets created by the Snort community. You have registered rules. These are free rule sets created by Talos. In order to use them, you must register for an account. They're very useful. And then, of course, you have your subscription-only rules. These are rule sets. These rule sets require an active paid subscription in order to be accessed and used. So I think it's about $39 per month that you pay to Snort. And this is very useful for companies whereby you're essentially outsourcing your threat intelligence to Snort, and based on the latest CVEs and exploits and intrusions, or really just exploits and threats, they develop rules for them, and you can then download these rule sets and ensure that your network is up to date with regards to detecting the latest attacks or intrusions, if you will. Or alternatively, we can write our own rules based on your own requirements, right? So we'll be exploring that as well. Now, whenever you're writing a Snort rule yourself, it's very important that you understand the syntax. As I said, it's very easy. Once you start writing rules yourself, it really is very easy. So the first segment here, and this is typically separated with this direction. So that's a hyphen and greater than symbol. So this is where you specify the rule header, right? And then you have the rule option. So this is the rule header. And then you're going to say, you're going to specify options pertinent to that rule. So in this case, the action is alert. So that means that in the case of this rule, when there is an ICMP packet or ICMP traffic coming from the following IP address from any port to any IP address and any port on the target network or the network that you are protecting or that you have Snort configured to monitor, then log the following. So the message is going to be, or send the following alert, and the message is going to be ICMP attempt attack, and then it has a signature ID, which you can essentially, create your own signature IDs based on your own requirements. So it really is very simple. So you're essentially saying the action firstly, which can be alert, drop, log, etc., etc. And then the protocol can be ICMP, TCP, UDP, IP, etc. and then you can specify the source the source IP address, and in this case you can also say any. So you can say any traffic coming from any IP address from any port that comes into our home network, which I'll explain, on a specific port or on any port. You then you essentially specify the rule option. It's really very easy. This will make sense once we get into the practical demonstration. So how does Snort work, right? So this diagram really explains what happens, right? So you have your network infrastructure, and then incoming traffic comes into the Snort host or the Snort server. And then you can see right over here, capture packets through sniffing. So it captures all the packets for all the devices or hosts on the network. It then goes through a preprocessor, and then it goes through the Snort plugin and packet decoding. And then, of course, it goes through the classification of the packets. And in the event a signature is matched, the alarm logging process is essentially implemented, where it's either logged or an alert is sent. And, it also goes through the Snort detection engine and rule set. And again, that all comes into the alarms and logging process or segment, in regards to how Snort processes or essentially handles traffic. And then, of course, it goes into a log file for analysis. Now, this is very important because I do know that this can be quite confusing. As I said, Snort can work in two modes, and this is very important, right? It can work as an intrusion detection system or an intrusion prevention system. Now, in this particular diagram, you have two use cases. The top one is whereby you can use Snort as an intrusion prevention system. So you have your internet, you have your router, and in some cases you may have a firewall, but you can disregard that. So ideally, you want to place the system that is running Snort between the router and the switch. So remember, all traffic, that means that all traffic is coming in through Snort, and it also goes out through Snort, right? So you want, in the case of an intrusion prevention system, or whereby you want to use Snort for intrusion prevention, then you want to set it up at a choke point, right? And that's fairly simple to understand. So that means that any communication coming into any of these devices within your network, your internal network, are all going through Snort, and it can then decide to drop packets based on the rules that you specify. Now, if you want to use it as an intrusion detection system, which is what we are going to do, you can see you have the internet, you have your router, a firewall. You're essentially connecting it to a switch. So if you're on a LAN, or if you're using a virtualized environment, like with VirtualBox, then the switch aspect is already taken care for you. So if you have more than one virtual machine connected to the same type of network adapter, then they're going to be connected to each other through a virtual switch. So ideally, you want to have your the actual server running Snort connected or part of the network that all the other VMs are a part of, which is what we're going to be doing. So ideally, this should fit within that network. So they're going to be on the same subnet, but they're all connected to the switch. So that means that Snort is essentially monitoring all traffic that is coming in and out of all the devices on the network, and based on that traffic, it tells you what's happening. So it'll tell you based on your rules whether there's an intrusion, whether a ping has been performed, etc., etc. So there's multiple ways of configuring it, and as I would say, if you are looking at implementing Snort as an intrusion prevention system, then this would best be implemented within a physical network, within a real network, as opposed to a virtualized environment. However, in our case, because I need to showcase this, I need to actually showcase how to use Snort as an IDS, we'll be doing it through VirtualBox. All right, so this is the lab environment. It's fairly simple. So we are going to have an external network. So this is where we're going to have the Kali Linux virtual machine. So this is running on another network adapter. So this is running on a NAT network. And then, of course, we have the following segment, which is the internal network, whereby we're going to have the VirtualBox switch here. And you can see that in this case, the subnet is 192.168.2.0/24. In your case, it's going to be different. Ideally, what I'm saying is all of these three systems, the Kali Linux VM, the Ubuntu 20.04 VM running Snort, and the Vulnerable Linux server, are all running on VirtualBox. However, these two are running on the same network or on the same network adapter, and this one is running on a different network, right? In order to simulate what would happen if external traffic, if there was traffic from an external system. And of course, you can also have this within the same internal network, because again, remember, we're essentially monitoring the traffic for our current or for, for the network that we are responsible for managing or securing. So regardless of what infrastructure you use, just make sure, the simplest way is just make sure that all three VMs are running on the same, in the case of VirtualBox, they're running on the same adapter and, are part of the same subnet. As long as you do that, then you'll be able to replicate what I'm about to show you. All right, so now that we have an understanding as to what intrusion detection systems are, what Snort is, how it works, the different types of rules, and the rule syntax, we can actually get started with the practical demonstration. So we are going to be switching over to the Ubuntu 20.04 VM, and I'll be showing you how to get Snort installed, and then we'll go through the setup and configuration process, and then we'll run a couple of tests, talk about writing our own rules, and we'll also be taking a look at the community rules. So let me just switch over to my Kali Linux, or my Ubuntu virtual machine. All right, so I'm back on my Ubuntu virtual machine. This is the same virtual machine we had used in the previous video for network traffic analysis with Wireshark. And I'm currently on the Snort website, which is available or accessible on snort.org. And I also have another website here that is that essentially hosts a tool called Snorpy that allows you to easily generate your own rules for Snort, which is absolutely fantastic. And I'll be covering how to use it in a couple of seconds. All right, so on the Snort webpage, where we are going to be utilizing we're going to be installing Snort through the Snort package, the Snort 2 package available, within the Ubuntu repositories. So I recommend following along with Ubuntu. It doesn't matter what version of Ubuntu, the Snort 2 package is available within the repositories and can be installed with the Aptitude Package Manager. So all you need to do to get Snort 2 installed rather, is to open up your terminal. And I'm just going to zoom in so you can actually see what's going on. And I'm going to say sudo apt get update, and make sure to update your repositories. I've already done that. I'm going to say sudo apt get install Snort. And I'm going to hit yes to, just accept the installation there. And it's going to begin the installation process. Now, this is very important, right? And let me make sure you can see that. I'm just going to go into my terminal, and I'll make sure that you can actually see the text displayed here. So when you're installing Snort 2, it's going to tell you that you need to configure Snort, right? So you can see that it tells you to specify the interface that Snort will be listening on, right? So as you can see here, it's essentially telling you to specify the interface that Snort should listen on. And ideally, if you've set up your virtual environment correctly, then if you type in ifconfig on the Ubuntu virtual machine, this is going to be your primary interface, right? So this is the IP on the subnet. You can see that the Snort virtual machine is going to be on 192.168.2.179. So we need to specify this interface. In your case, it may be Ethernet 0, Ethernet 1. All you need to do is just take note of that. In my case, it's ENP-S03. Let me make sure I've got that correctly. So that is ENP0S3. So again, make sure you type that in correctly. So ENP0S3, hit enter. It's now going to ask you for the actual address range for the network, right? So this is where you specify the actual network range. In my case, or in the case of VirtualBox, if you are using it, in my case, it's 192.168.2.0/24 because there are 256 addresses, as it explains here with the CIDR annotation. So, make sure that you're specifying the correct CIDR, the correct range for your network, right? So in my case, that is the actual address range for my local network. You can identify this information if you're a little bit confused by opening up your terminal, or another terminal for that matter, and typing in IPAS. And if you take a look at the interface here, your main interface, you can see that under INET, it'll actually tell you the actual network range. So just make sure you replace the actual IP here to 0, and because we're essentially specifying the entire range of devices or IPs. Once that is done, just hit OK. It's then going to complete installing Snort. So we'll give that a couple of seconds. It's going to again ask you to essentially specify the interface or the interfaces which Snort should listen on. Now, if you are using Snort as an intrusion detection and intrusion prevention system, then this is where you typically specify both interfaces, right? So you, if you're setting up Snort on a bare metal server, then you need to have two network interface cards, whereby the first network interface card is where the traffic comes in from the router, and the other one is connected, is essentially connected to the switch, or based on the diagram that I highlighted, is essentially what goes into the switch, and that supplies the traffic to the actual network or all the devices that are part of that network through the switch. And in order for that to work, you need to enable or set up port, or you need to be able to forward traffic from one network interface to another. Now, this is beyond the scope of what we'll be covering, because we really don't need to do that. So again, I'll just hit enter here. And we'll give this a couple of seconds to complete. There we are, it should be done. And there we go. So we can confirm that Snort is installed by saying Snort version. And you can see Snort version 2.9.7.0 build 149 is installed. Fantastic. And it has all the dependencies installed. So libpcap for capturing traffic. And of course, this is what Wireshark uses to essentially interact with the actual PCAP API. So now that that is done, we need to configure one more option, and that is to essentially enable promiscuous mode on our current interface. And again, the reason I'm saying this is even with VirtualBox, if I just open up my VM settings here, one thing that you want to do is open up your settings for this particular virtual machine, head over into network, and make sure that promiscuous mode is set to allow, under advanced, make sure it's set to allow all. Now, if you're not running this as a virtual machine, then what you'd need to do is say sudo IP link set, and then you specify the name of your interface. So enp0s3 promisc on. Hit enter, and that'll essentially enable promiscuous mode. All right, now, if you want to take a look at the actual man pages for Snort, you can do that as well. I'll be explaining the most important commands, but this is a really fantastic resource. If you're ever confused as to what's going on, then do the first place I recommend you check is the actual man pages. So you have your standard options here, and I'll be explaining them as we move along. So you can go through that. Now let's talk about configuring Snort. Now, the default configuration file for Snort is stored under the etc directory, of course. So if we open up we display the contents of the etc Snort directory, this is pretty much where you'll be making all your changes, right? So you can see that you have a rules directory. That's where the rules are saved. Now, by default, the Ubuntu Snort 2 package comes prepackaged with quite a few community rules and a few rules developed by Snort themselves. I'll get into that in a second. And then you have the main configuration file that is called snort.conf. This is arguably the most important file that you will be using to configure Snort, and it's really the core of Snort functionality. So what I recommend you do if you're a beginner is make a copy of that file, because if you're a beginner, you are likely to make mistakes. I'll be explaining the format and the structure of the configuration file in regards to what is most important to us. All right. In my case, I know what I'm doing. So, I can essentially just modify it and use that as my own. Now, one of the great features of Snort is that it essentially allows you to make a copy of this configuration file with another name. So it could be Snort test.conf, and you can essentially run Snort with that configuration file as opposed to the default one. However, as I said, in my case, I don't really need to do that. Also take note of the actual permissions required to make changes to this file. I'm currently using an unprivileged user called Alexis, who is part of the sudo group, which means I can directly, run Vim or any other text editor to modify it. So I'll say sudo vim etc snort, and we can open up snort.conf, right? So I'm going to say snort.conf, and my bad. I'm just going to open that up again. So snort.conf, there we go. All right, so this is the snort configuration file. Now, one area that you should take note of is this index of sections within the configuration file. All right, so section 1 essentially covers the process of setting the network variables. You can then configure the decoder, the base detection engine, the preprocessors, the output plugins, your rule set, and the other community rule sets, etc. Now, the most important options are going to be under step 1, where you set the network variables. So you want to scroll to the IP variable HomeNet variable, right? So for HomeNet, what we want to do, this is essentially where we specify the actual subnet, or the actual network that we want to monitor, right? Or that Snort is going to monitor. So in my case, I already know that because I had specified it. That is going to be 192.168.2.0/24. Now, the external network addresses, as it says here, leave as any in most situations. So this, as I said, I would recommend leaving it as any, because ideally you do not want to confine this variable, the external network variable, to a specific subnet, because attacks and intrusions can come from any network or any IP address or any subnet, if you will. All right, so that's the first option. Now, one of the great features of the Snort configuration file is it allows you to list, specific hosts that might be part of the critical infrastructure of a network. So it allows you to specify the actual list of DNS servers on your network. So you can replace the HomeNet variable with the IP address of a DNS server on your network, an SMTP server, a web server, so on and so forth. For now, I would not recommend playing around with that. You can also modify the list of ports where you can run web servers on. So this will tie into the actual intrusion detection process. As I said, I recommend leaving this as is for now. What we want to do is we want to take a look at the path to our rules file. So just below the actual network configuration, we have the rules section here, right? So this allows us to specify firstly the rule path, and by default the rule path, the rule path variable essentially points towards etc snort rules, which is perfectly fine. All right, so we just take note of that directory. So that means that this configuration file will essentially pull in rules or load in rules within that rule path directory. So leave that as is. What we want to do now is we want to head to the bottom of this file. So you can use the page down key, and we want to head over to the rules section. All right, which should be, there we are. Here it is. Right, so this is step 7, customize your rule set. Okay, so again, site-specific rules. This is, in this particular case, we're essentially saying the rule path. This is where you can essentially specify the actual rules file that contains the rules that you'd like to use, right? And by default, your predefined rules that you will be creating yourself are going to be stored or can be written in a file called local.rules, and that file is stored under etc snort rules, and the name is local.rules. So this file is already created. Again, remember, this file is for the rules that you will create yourself. So it currently is empty. And then the include files commented below have been disabled, and in some cases we have a few that are enabled. So to disable a rule file, just comment it with the hash or the pound symbol. So they've been disabled because they're not available in the stock Debian rules. So if it is disabled and it is commented, then that means that it's not available within the etc snort rules directory. If it is enabled, then that means that these rules are already existing. And as I said, most of these have been developed by Snort and the community. So that means that these are available and are active. So what does this all mean? It means that when you run Snort, there are essentially going to be two segments of rules or two categories of rules that will be loaded. You have your local rules, which will contain your own predefined rules. And then if you have any other custom ones, then they can be specified right over here, right? And they'll all be loaded. So I really like this organizational structure because it allows you to separate between, community rules or rules developed by Snort and your own rules. So you have two files, you have one file for your own rules and then a list of other rule files for community or for community rules or rules developed by Snort. So you can see you have DDoS rules, DNS rules, DOS rules, exploit rules, and these default ones are really, really helpful. And then, of course, you should have the community or a few community ones here. There we are. So we have a few community SQL injection rules, web DOS rules, etc., etc. So we pretty much at this point do not need to do anything. However, for me to explain how things work, what I'm going to do is I'm just going to write the changes that I made so far. What I need to do firstly is we need to test and see whether the changes we've made to the configuration file are valid and if there are any syntax errors at all. So I'm going to write and quit, and we'll get back to that file. Now, in order to test a configuration file with Snort, we need to run Snort. So Snort requires root privileges because we're capturing traffic. So we'll say sudo, and we will say Snort, and we'll use the T option. And again, if you want to learn what that option does, I'll just open this up here and I'll search for that specific occurrence. So this is this will start up Snort in self-test mode, and we'll check all supplied command line switches and rules. So in this case, we're testing the configuration file. So I'll say sudo, and I will say Snort T, and then you specify your interface. Now this is very important. So if you're running this or you're following along here, then you just specify the interface that you're going to be monitoring, or that Snort is going to be monitoring. In our case, it is, or in my case, it's ENP 3SO or 3S0, and then you specify the configuration file. So etc snort and snort.conf, and it's going to run a check on it. Sorry, that we need to specify the C option. So that specifies the configuration file. There we are. And it's going to generate quite a lot of output. So, given the fact that we have a few community rules here, it's going to give you a few errors telling you that they could be duplicates. Don't worry about that. As I said, we'll actually get into disabling that in a second. The most important piece of diagnostic information is going to be this this set of lines here. So it's going to tell you how many Snort rules have been read or imported, and you can see we have 3,476 detection rules. All right, so 3,476 option chains linked into 290 chain headers. So it'll then sort the actual rules based on the type of ports or the protocol, so TCP, UDP, ICMP, and IP, and the actual type of connection. So whether it's it's coming from any address, etc., etc. Right now, in order to learn how to use Snort, I would recommend disabling those the actual rules developed by Snort and the community. So what we're going to do is we're just going to go back into the configuration file, and we are going to comment all of these rules, all of these custom rules. So let me just modify my Vim correction for the root user so that we can actually see the line numbers. So set number syntax on, so that when we open it up again, we now have line numbering. So I'm just going to scroll to where those custom rules are specified, and we're just going to comment all of them. So in order to do this, we know that the rules start, remember, we want to leave the local rules specification on. We want to get rid of all of these ones here. So the line starts at 578, and I know that it ends at 669. No, not 69. 696. There we are. So to add a comment in front of all of these rules to disable them, what we're going to do is I'm just going to use the colon functionality within Vim, and I'm then going to say from line 578, 696, what we want to do is we want to at the beginning of each line, so let me just say the beginning of each line, we want to add the pound or hash symbol. I'll hit enter, and as you can see, it does it. One of the great, reasons to use Vim. So you can see it only does it for the lines that we specified. So now the only rules that will be loaded are going to be within the local.rules file. So I'm going to write and quit, and if we run the actual self-test again, you can now see that we don't get any of those errors that we got in regards to having duplicated SIDs or signature IDs. So 0 snort rules read, 0 detection rules, 0 decoder rules, etc. All right, so we currently do not have any rules, within the local.rules file. Now, let's start off by creating a few basic ones, right? Now, in order to create one, we're going to say sudo vim, and you can use any text editor that you're comfortable with, as long as it has the permissions to make changes or to write changes to these particular files. So etc snort, and we are going to go under rules, and the name is local.rules. As you can see, it's empty, so this file intentionally does not come with signatures. Put your local additions here. Fantastic. So let's start off with a few examples. All right, so let's say we wanted to detect any ICMP pings, right? And I'll actually talk you through how to use Snorpy in a second. But the syntax is very simple. So you start off by specifying, if we take a look at Snorpy, the action. So with snort, we can alert, we can essentially, send an alert to the terminal. We can log that particular packet or network activity. We can pass the packet. This is in the case of the intrusion prevention system. Dropping and rejecting are also part of the intrusion the intrusion prevention system or functionality of Snort. In our case, we're primarily focused on alerts and logs. And in our case, in pretty much many or most cases, we want to use the alert option. So I'll say alert. So that's what we're essentially saying here is, for any of the following traffic that I specify, I need you, Snort, to actually, provide me with an alert whenever a ping is made. So in order to do this, we're going to say alert ICMP, because pings essentially send ICMP requests from any network and any port. And then we say that comes into our home network. Remember the home network variable that we had configured within the Snort configuration file. So we're essentially saying that subnet, or what we're saying is, I want you to generate an alert for any ICMP traffic that comes from any external address, with any external port into our home network subnet. And then you specify the port. In our case, we'll say any, because pings are really not targeted towards any specific port. And then we specify, in the case of an alert, we specify a message that we would like to display. So in this case, we can say message, and I'm going to say ICMP ping detected, and that's what's going to be displayed to the relevant user. That's essentially monitoring the actual intrusions or the traffic. We then need to specify a signature ID. This can be whatever you want it to be. It's generally recommended to have this to essentially provide a unique value so that it doesn't conflict with the other signature IDs. So in this case, we can just say signature ID is going to be maybe, we can say 10,001, and we then want to use a semicolon, and you can then specify revisions for specific for specific rules. So in this case, we can say this is a revision 1, and we then close the brackets there. So that is a Snort rule. All right, so we have created a Snort rule. Fantastic. And you can keep on adding other rules on the next line. So let's write and quit. All right. And what we are going to do now is we are going to run Snort. Now, in order to run Snort, you need to understand a few options, right? So whenever you're running Snort, the most important option is the alert mode, right? So the alert mode allows you to specify what types of, the actual format of alerts. So, for example, the fast alert mode writes alerts to the default alert file in the single line syslog style alert message. Full writes the alert to the alert file with the full decoded header as well as the alert message. And in our case, we're not really going to be logging the alerts. By default, we're going to be logging the traffic, but we can essentially specify this to either be fast mode, but in our case, we're going to say log all the alerts onto the console. The other option we need to use that we're going to be using is the L option, which allows us, if I can find it here, there we are. So this is the log directory. So this will set the output logging directory to log directory. We'll be using that, and we'll be specifying that we want to save all our logs under var log snort. This is very important because what's the point of performing network intrusion detection if you're not logging all the relevant alerts for later analysis or for implementation or integration into a tool or a visualization tool like Snort? The other option that we're going to be using, of course, is going to be the interface option. We will be specifying our interface. We then need to specify the queue option, which I believe in this case is quite important. We want Snort to run quietly. I don't want it to display all the diagnostic information in regards to the rules loaded, etc. So MNOPQ, there we are, quiet operation, don't display the banner, and initialization information. If you are running it as an intrusion prevention system, then you never want to use the capital Q option, because that will that will enable inline mode. So yes, when you're running it as an IDS IPS, then you need to use the Q option to run it in inline mode. In our case, we're not doing that. All right, so to run Snort, there's a few arguments we need to specify. So we'll say sudo snort. We're going to run it in the quiet mode. The log file is, or the log directory is under var log under snort, and what we can then specify now is our interface. So enp 0s3. In your case, it's going to be different, so do take note of that. And then the actual alert mode is going to be console, because we're displaying it to ourselves. We're not yet logging them. And then we need to specify the configuration file that we're going to use. If you've created a custom one, then this is the best time to add it here. So we're going to say cd etc snort and snort.conf, and we can hit enter. Now, if it doesn't provide you with any output or any errors, then that means it's working. So let us actually test this. Let's see if this is indeed working. So I'm just going to open up a command prompt here, and there we are. I'm just going to clear that out, sorry, CLS, and I'm just going to perform a ping, right? Now, this device is part of the network, is part of the actual local network. So I can ping a particular device that is within the network. But before I do that, I actually want to fire up the Linux virtual machine. That is the Metasploitable 2 virtual machine that is going to run within the network. We're then going to ping it with our Kali Linux VM as well. And you'll actually see the traffic here. So let me just start the VMs and we can resume from that point. All right, so I've started all the VMs, including the Kali Linux VM. And what I'm going to do is I'm going to run a ping on the Metasploitable 2 server. So I'm going to say ping, and the IP address in my case of the Metasploitable 2 server is on 192.168.2.157. All right, so I'm going to hit enter. And now if we switch back to the Ubuntu VM running Snort, we should see these alerts. So back on the Ubuntu VM running Snort, you can actually see the pings being detected based on the rule that we created, which is fantastic. And I'm just going to terminate that particular ping on the Kali Linux system. So I'll just Control-C that. And let me switch back over to the Ubuntu VM. And you can now see that the alerts have stopped being produced, which proves that it is indeed working. So the format is very simple. You have date time, and then of course you have the signature ID, then of course the message that we specified. So ICMP ping detected. We can also specify a priority, the actual protocol, the address it came from, and the address it went to. So this is the IP of the Metasploitable 2 virtual machine. This is the IP address of my Kali Linux virtual machine where I performed the ping from. Fantastic. So that's how to create a very simple rule. I really like using this example because it allows me to showcase a few important techniques. All right, now what I'm going to do now is let's write another rule for SSH connections, right? Because that can be quite important to monitor on a network. So I'm going to go back and modify the local.rules file, and I'm going to create another one. So I'm going to say alert. And in this case, because SSH runs on TCP, I'm going to say TCP from any connection on any port. We want to essentially generate an alert whenever it comes into the home network subnet on port 22. Remember, we need to specify the appropriate port for SSH because otherwise the rule will not work. We then create a message, and the message can be anything. In this case, we can say SSH authentication, and because we can't, at this point, we're not really, going deep into determining whether this is a connection, a successful authentication attempt or a failed one. We're just going to say SSH authentication, and we can just say attempt, right? Just to give it a bit of nuance. And then for the signature ID, we're going to make sure it doesn't conflict with our previous one. So we'll say, 10,002, and we'll just say revision is 1, and we can close that up. And now I'm going to write in quit. And if I go back onto my Kali Linux system, we're going to try and authenticate with Metasploitable 2 via SSH, because that Metasploitable 2 system has an SSH server running on it. So I'll just switch back to Kali here in a second. There we go. So I'll say SSH, the username is MSF admin, and I'm going to say 192.168.2.157 and MSF admin. There we are. So we authenticate successfully. So what we're trying to do here is try and see from the perspective of the defender what this network activity looks like. And if they have written rules for it, then they should be able to detect what's being done on the network. That's the essence of intrusion detection and network traffic analysis, right? In the case of network intrusion detection, we're essentially fine-tuning our network traffic analysis to identify and automate the process of identifying intrusions or threats. So let me switch back over into my into the actual Ubuntu VM, and I had actually not started up Snort. So let me just do that again, and I'll just do it again, and we can run that authentication attempt once more. So I'll just exit and I'll run it again, and I'll just provide the password there, and I'll switch back over, and you can see we get the SSH authentication attempt alerts. Fantastic. So you can now start to see how cool this is. And of course, this will also work for all the other rules that we specified. So for example, I can I can actually ping. So if I say ping 192.168.2.157, you can see that ping is detected. So really robust network intrusion detection system. And the power of your network intrusion detection system will be based upon your rules. Now, as I said, the reason why I disabled the other ones is because I wanted to showcase how you can write your own. So let's explore how to use the Snorpy tool, right? So the Snorpy tool is essentially a graphical user interface that allows you to simplify the process of creating a rule. So it's really very simple. You specify whether it's an alert or whether you want to log it, etc. You then specify the protocol, right? So, we can say TCP. In this case, we can say any connection from any address into our home network. So we'll specify the variable, so home network. So you can see it provides you with the fields, and you can easily specify or create your rule. And at the bottom, you can actually copy it and paste it within your local.rules file. In this case, let's see if we can create a rule for FTP. So FTP is on port 21, signature ID. We'll give that 10,003, revision number 1. We can also specify the rule message here. So we can say, in this case, FTP authentication attempt, right? And we can also limit the actual, or we can also specify what IP we're interested in. So instead of looking for all FTP connections coming into the actual network, we can specify only alert us when there's an FTP connection made to a specific IP within our network. So in this case, we can specify the IP address of the actual Metasploitable 2 virtual machine FTP authentication attempt on MS2, right? And we can then specify additional options if we require them. In this case, I'm just going to copy that there, and we'll go back here and we'll just terminate snort, and we'll go into our rules here, and I'll say insert, paste that in there. Let me just make sure that that is displayed correctly and there aren't any issues. Yep, that looks good. So Snorpy is really useful in this way. Write and quit, and we'll start up snort again. And I'm just going to make, or we can actually authenticate with that with Kali Linux, with MS2 with Kali Linux. So I'll say exit FTP 192.168.2.157 on port 21. Hit enter. MSF admin, MSF admin there. There we go, etc. All right, so let me switch back over. There we are. You can see that in this case, when we started it, it looks like there was an SSH authentication attempt. I believe that is the case. That was on port 22. I'm not really sure why that was logged, but hey ho. As you can see, it actually logged the actual FTP authentication attempt on the Metasploitable 2 system. So from this example or exercise, you can start to get a feel and understanding as to how robust snort rules can be. And this is obviously made evident by the by the really awesome rules that are written by the community and by Snort themselves. All right, so again, I would recommend taking a look at Snorpy if you want to learn how to write your own rules. Another great resource to learn how to write your own rules is to take a look at the rules written by the community. So let's take a look at a few examples. Now, the first thing we would need to do, of course, is to disable or enable the rules we had disabled within the configuration file. So I'll just modify that file now. And we are, sorry, that is still the rules file. We want to modify the snort.conf file. And we want to head over to the lines that we had commented, right? Because those rules are very, very important. So we want to uncomment the ones we had commented earlier on. So in order to do this with Vim, we're just going to specify the start line, which was 578 and 696. For the end line, and we are then going to say the start of the line that begins with a hash or a pound, just get rid of that. Hit enter. That gets rid of the comment for the rules that we had initially commented, so it'll still maintain the initial comments that were specified by default. So let's write and quit, and let's take a look at the community rules offered by Snort. So if you head over into your browser on snort.org, you can actually download rules, right? There we are. And right over here, as you can see, for Snort version 3, you have the ability to download those rules. And for Snort version 2.9, you can download those rules there. So you can click on that. And you can open up your downloads directory. And you can extract that. Ideally, it's recommended to extract that within the actual etc snort rules directory. But I'll just show you an example as to how you can learn how to write really complex rules and the options afforded to you. Right, so I'll extract this here. This will contain a snort.configuration file based on the rules, on these particular community rules. So if you take a look there, you can see that it still utilizes the local.rules file. And then, of course, it has all of these other rules here. And if we take a look at them closely, I think we would need to include them. But what we can do is we can identify the rules that we're looking for as an example. In this case, they're going to be under community.rules. There we are. So this is essentially a set of rules that allows you to detect exploits, intrusions for specific CVEs, malware network activity. So, for example, in this case, you can see that alert, for TCP connections coming from an external network into the home network subnet on port 7597, then that is logged as a malware backdoor QAZ worm client login success. And you can also specify the TCP, the actual TCP flow and the actual state. I'll get to that with Snorpy in a second. But one really cool example I can showcase here is the Eternal Blue attack, right? So Eternal Blue, I can search for that alert here. And what I'll do here is let me just open up my preferences so you can actually see it. There we are. So this is the Eternal Blue alert. So Eternal Blue is a Windows exploit or vulnerability within the Windows SMB version 1 that allows you to perform remote code execution. So I can spin up a Windows 7 virtual machine and we can try and exploit it with Metasploit from the Kali Linux system, and we can add this rule to our custom rule or to the local.rules file, and you'll be able to tell that Snort will be able to identify that as that exploitation process as an intrusion or malicious. Now, one of the great things with Snort rules is they allow you to also specify these a reference point, so you can specify the CVE code as well as the URL where you can actually read more about a specific vulnerability. So what I'll do is I'll copy this and we'll modify the actual local.rules file. I'll put it in there. As I said, you can actually copy that community.rules file into the actual Etsy Snort rules directory and load those rules as well. But I typically like loading the ones that I'm interested in, especially if you're learning. This is really a really cool way. So we can put it in there. The only thing you need to make sure you do is make sure that the signature is unique, or the signature ID, right? And that looks fine. So you can see what's happening here is what we're telling Snort to do is alert us if there's any TCP connection coming from any network into our home network that connects to any device on our home network on port 445, whereby the flow is the actual flow is you can see to the server established. So that's the TCP state, and the content, this is where you would specify the signature. So based on the content contained within a packet that is used to perform the Eternal Blue exploit, this is where you specify the signature. So in this case, you can see it's it looks like it's hexadecimal, and then of course you have the byte extract there, etc., etc. We're not going to be exploring how to write complex rules, based on specific exploit signatures, but most of them have already been written for you, so you can actually test them out on your network. Another good example of this is, let's see if we can identify whether the latest vulnerability log4j, there we go. So you can see an alert has been made for log4j, and you can now start to see the power of Snort and the actual Snort rules, because if you use the latest version of this community.rules file, then that means that you're up to date with the latest vulnerabilities and you'll be able to detect them as they occur on your network, which is absolutely fantastic. So let's just use this simple example. So I'm going to write and quit, right? And we can actually start it up. So we're going to start up Snort here, and I'll hit enter. So I'm going to fire up the Windows 7 virtual machine for the purpose of this demonstration. And I'll then switch over to Kali. We can exploit the vulnerability and see whether it's logged right over here on our console. So let me just fire up the VM. All right, so we have Snort running. I've started up the Windows VM. I know the IP address, and I'm currently on the Kali Linux virtual machine, and we're going to be utilizing a popular exploitation framework called Metasploit that already contains a pre-built exploitation module that allows me to exploit the Eternal Blue vulnerability on affected versions of Windows 7 being one of them. So, in this scenario, just assume that you had a Windows 7 system on your network and it was vulnerable to Eternal Blue, and an attacker had gained access, and you would be able to essentially identify that this attack was being performed. So I'll just say use that module here. So I'll say use, paste that in there, and for this module the only option I need to set is the target IP. So this is the IP of the Windows VM. So the IP address is 192.168.2.35, and I can then hit exploit, right? And this should provide me with elevated privileges on the Windows system if successful. So based on the way this exploit works, I should be able to detect this attack as a defender by taking a look at the alerts generated by Snort based on the rule that we created, right? And if we had implemented or loaded the entire set of rules within the community.rules file, then this would be the case anyway. But again, I just wanted to showcase how you can also, identify specific CVEs and vulnerabilities and exploits, right? So let me just switch over back into the Ubuntu VM. And there we are. You can actually see it live. So There we are. We have, based on the other rules that we had enabled, we have a few other alerts here. So you can see bad traffic, potentially bad traffic. And then, of course, we have that rule here. The eternal blue alert is generated. So OS, Microsoft Windows, SMB, remote code, execution attempt, classification, attempted administrator privilege gain, priority 1, where the attack came from, and it's the port it came from, and the actual IP address of the Windows system on port 445. And there are going to be multiple alerts because the exploit sends multiple packets. And of course, we have these additional ones. So you can see in order for this to work, because this exploit targets SMB, you can see there we are. We have a NetBIOS alert that tells us that an SMB IPC share was accessed by the following IP. So you can actually see how useful this is. So I'm just going to terminate the exploit, and we can take a look at the final section of what I wanted to cover. All right, so the final section that I wanted to highlight was logging and where all of this information is being saved. So if you, let me just terminate Snort here. If you take a look at the command that we used to run Snort, you can see that all logging was, all the logs were saved under var log Snort, right? However, the actual alerts were displayed on the console. So the only thing that was logged was the traffic, which is very important to understand. So let's open up my file browser here. And if I go into the var log directory, so var log, and we go into Snort, we'll be able to see some interesting files. So these are all the log files that were created by Snort. And these are essentially this is essentially the raw packet capture on the network. So this doesn't have any alerts attached to it. And these can be accessed with Wireshark. Now, in order to access these log files, you need to run Wireshark as root because these are owned by the root user. So we'll say sudo Wireshark, and I'll show you that, Snort really is extremely powerful. So I'll say file open, and I'll go to my computer, and I'll say var log, and we'll head over into Snort, and we'll open up the latest one that contained the actual Windows SMB traffic. So I'll say open, and there we are. So all the packets were captured directly or immediately from the actual SMB exploit, and you can see all that traffic was captured. So all the packets have been captured. That's not a problem. I want to cover how to log the actual alerts, right? And any other type of either alerts or, if you want to log all alerts, because the actual alerts are pretty much the most important piece of information. And if you're not logging them, you should be. So in order to log them, what you need to do is we'll use the same format where we specify quiet mode. We're logging into the following directly under the following directory. However, for the actual let me just show you this right now. So man Snort, for the actual alert mode, we are going to be using either fast, full, or none. In the case of fast, this will write the alert to the default alert file in a single line syslog style alert message. That is the preferred format if you're going to be using these logs or importing them into tools like Splunk. So in order to do that, we're going to say, instead of console, we're going to say fast as an example, right? So let me just type that in here, and I'll hit enter. And let me see if I can generate some traffic. So let me just generate some traffic. All right, so I've generated some traffic, and you might be thinking to yourself, what on earth is happening? You've generated traffic, or you've performed a few pings and you've connected to the FTP server on the Metasploitable 2 virtual machine. Why isn't anything being displayed here? Well, that's because we specified to Snort that, hey, I want you to log all alerts under the following using the actual alert method. And of course, this is the alert mode. In this case, we specified the alert mode is fast, which is the preferred format, under the var log Snort directory. So we were already in that directory, and we can see it right over here. So it's generated a log file called alert. So if we open this up, there we are. We get the actual traffic that I had essentially generated, where I performed a few pings based on the rules that I'd actually created. we had an FTP authentication attempt and some potentially bad traffic right over there. So now at this point, we can utilize this format, this logging format, to essentially import this into tools like Splunk. So again, once you've got all of these logs, they can be analyzed, on this system, or as I said, you can configure a log forwarder to essentially have them dynamically loaded, have the latest logs or alerts dynamically loaded onto a tool like Splunk for analysis. And at that point, then you'd essentially be able to know what was happening on your network in regards to attacks and intrusions directly from Splunk, which is absolutely fantastic. So that is going to be it in regards to what I wanted to cover. We've covered quite a lot. Hopefully by this point you should know how to get Snort installed, how to customize and configure it, how to create your own rules, how to load in community rules, how to write rules, and of course how to log the actual alerts that you've captured, as well as the packets that you are capturing. With that being said, let me just switch back over to the slides. All right, so as a parting note, all the links and resources used in this video will be added to the description section of this video, so you can check them out. You'll also be provided with access to the slides as a reference, so that you can actually navigate through this video. If you have any questions or suggestions, leave them in the comments section, or you can reach out to me and the Hackersploit community on our Discord server. The link to that is also in the description. In the next video, we're going to be taking a look at threat detection with Wazoo. With that being said, I will be seeing you in the next video.